All right. Let's match the common acid with the source of the acid. Am I going to find these guys? Most look pretty good. All right. So remember that lactic acid is in dairy and that yogurt is a kind of dairy. So that was probably the one that didn't give you the direct ones. The others. So if you've ever seen like those hacks that they have on the internet of like, you can do this, or, this is, so acidic because blah, blah, blah. One of them will be like, you can clean your dishes by pouring, Dr. Pepper in there. Well, Dr. Pepper, Coke, or Pepsi, or whatever is going to have that phosphoric acid in it. And if you have dishes that have some of that lime scale on it, like if you have clear glasses that are starting to look kind of cloudy, that's going to help dissolve that. But that's what, if you see the little bottle of like Finish that you put in your dishwasher, that's the same thing. It's just a strong acid that's dissolved. All right, let's see. Calculating pH. So if you have a calculator, you might want to have it out. I did put out some calculators, some of these white calculators. So when you are calculating a pH, you'll be given a number for this. So this square bracket here means the concentration. So they'll say the concentration is this. And the way you do it is you say it's negative log of that. But most calculators, so these are if you're using the calculator on your phone, they input logs in reverse. So what you have to do is put in the number first and then hit the log button, and then hit the button that has a plus minus on it to make it negative. Or you can just look at it and be like, oh, there's a negative sign. That should be positive. That works as well. Okay, so that's how you do the calculation. I got a couple more calculators. Anybody want one? We're going to try this with a couple of things. So, we said that the scale goes from 0 to 14. We're going to do the pH as negative log of the concentration. And remember this, H plus is the same thing as the H3O plus. We use those terms interchangeably. So don't get confused by that. We mean the same thing. So if water has a concentration of H plus, I said 1 in every 10 million. So that's what this number is, 10 to the negative 7. So the way you would put that into a calculator is you would type 10, and then there's a button that says X to the Y. So chalk. It's like this, X to the Y. Or on some calculators on your phone, it might look like this. Either one of these, you push that button and then push -3. Okay, sometimes it wants you to put 3 and then negative. I don't explain calculators. I just tell you what they do. All right, so you're going to put that in. Then you're going to hit the log button. And it should give you -3 at that point. So if you hit the plus minus button, I'm sorry, not 3, 7. I typed in the wrong number. You should have 7 for your pH. If you typed in 10, did this, and then did your 7 and negative, and then hit the log, you might have gotten an error. If that happened, just hit equals after you do this part, after you type in the 7. And it should look something like 1 and a -0.7. That's the point where you want to hit. Now, if you have a graphing calculator, or if you have a calculator that is fancier than one of these, then you can usually just put it in the same order. Okay, but usually it's just the science majors that have those, or the math. All right, stomach acid is 10 to the -1 for the concentration. So this is what we put in. What's the negative log of that? Water gave us a pH of 7. Okay, so we're going to do 10 to the, this is going to be a 1. And once you see this, you hit log of that. Surely somebody can get that. And I'm going to hit this button right here. So I'm going to make you guys do this on a quiz. So you want to know how to do this. We hit this button, X to the Y. Then I'm going to put the 1 and then this plus minus button. That's the negative. Hit enter. Now, instead of it writing it like this, it changes it to decimal form because it's so small, but this is what that is. So it's basically 1/10, right? And so then I'm going to say log of that. And then I'm going to do the plus minus again. So my pH is equal to 1. Okay. If I were doing, let's say, 10 to the negative 9, so that's pretty close to what the baking soda was. I would do 10 to the 9 plus minus. So it looks like this. So it has this form. That's because there would be so many zeros. It doesn't want to write out all those zeros. And then I would hit the log button. Gives me a negative number, so I hit plus minus, and that's 9. So what pattern do you notice happening as we do that? Yeah, the exponent there tends to be the pH. Where is it? Wrong one. So we can approximate that pH by looking at the exponent, but if we had something other than 10 to the, like if it was 9.5 instead of 9, then that would change how that would work. So that's why we actually have the formula. Okay, so in this case, we said 10 to the minus 1 was 0.1. That's why that showed up on the calculator. The pH was equal to negative log of 0.1, and that was 1. Okay, so now, what is the pH? I forgot that this was the question on here. You're paying attention? 9. Look at this exponent here, and that tells us what it is. Now, if I have something other than just plain 10 to the, it's going to be close to the exponent, but it'll be a little bit less. So this one here, we have 6.2 times 10 to the negative 4th. So let's go back and look at how we would put that into the calculator. Okay. So I'm going to, I forget what the number was, 6.2 something. 6.2. And then I'm going to hit this EXP button down at the bottom here. So that means times 10 to the. So times 10 to the, and then these zeros here are going to be what that exponent was. So let's say it was times 10 to the negative 4. But like I said, I don't remember. I'm going to do the 4 first and then the negative. So that gives me my number. If I want to make sure that it's in there, I can hit the enter sign. And then I would hit log and negative of that. Okay. Let's go back to the question. Yeah, so that was, I remembered it correctly. So the Scott County schools are on spring break right now. And Dr. Hughes's kids are therefore not in school. And that is why you hear them in the hall today. So yeah, we got most of you right in that right ballpark there, 3.1 to 3.23. It looks like a few of you put the negative of that. So remember, we want to make that positive there. And we got a couple of other responses. So remember, the exponent was to the negative 4th. So I said it would be a little less than that. So that's how we ended up with the point. All right. So what about acids in food? So a lot of our foods are acids, but they also can affect the foods that we eat, sometimes with the flavor because they taste sour, but also because of the proteins. So proteins, remember, have this really complicated structure. They might have spirals and they're all folded up and whatnot. Acids are going to affect it in a couple of ways, because as those hydrogens attach themselves to the proteins, they can cause them to unfold, which is denaturing, and to clump together, which is coagulation. So if you take a raw egg and just put it into something like a vinegar, the shell will dissolve away, and then the acid will seep into the egg and the proteins will start to denature. So you see, instead of this being clear here, it's starting to look like a hard-boiled egg. So this one isn't completely denatured, but you can have it denatured all the way. So I was talking to Dr. Fraley. He's one of the other professors here, and he used to work at Procter & Gamble. And at Procter & Gamble, they worked on cleaners, dishwashing cleaners and that kind of thing. And he said that they tested bases as well to see if they could get egg off of plates. And they found that it worked really well if you had a pH of 7, if you had a pH of 8, if you had a pH of 9. But when the pH got really high, it stopped working because this same thing happened. So if I took bleach and put it into an egg, it would start to denature as well. So I've put a basket in front of most of you that you're going to try a couple of things. So you have a little container that has some egg in there. Now, when egg has proteins in it, this white part is called the albumin, and the albumin is kind of watery, but it kind of has layers in it where there's one part that's very close to the yolk, which is thicker, and then the part that's further out is more watery. So what I want you to try and do is pour about half of it into one cup or into the other cup, so you have two portions that you can kind of play with here. But what you'll find is that thicker part is going to want to stick together. So you may have trouble getting it to be exactly half. That's okay. And then you have a bottle labeled with vinegar, which is also acetic acid. And you're going to try a couple of things. So you're going to use your dropper to squirt some acetic acid into one of the cup of eggs to see if you can get it to turn white. That means that it is coagulating the protein. And then you're going to pour some vinegar into the cup with the eggshell. So for the eggshell, that is a base. It is calcium carbonate, and you should see bubbles forming as the carbon dioxide breaks away from the calcium carbonate. Okay, so we should see that reaction as well. And then these are Sour Patch Kids, and I mentioned that these have the citric acid on them. I haven't tried this before, so I don't know if this is going to do anything, but stick one or two of these in your other cup of egg and see if the citric acid is enough to denature the protein right around the Sour Patch Kid. Take a minute or two to do that. See if you notice any results. And for those of you watching at home, I'll show you examples once they have a chance to do that. So I mentioned my family likes to drink tea. One thing that I learned pretty early on is that acids like lemon juice, which people often have lemon juice in tea, will also denature the proteins in milk. So if you have both lemon juice and milk in your tea, the milk is going to clump up and you'll have these little clumps of milk floating around instead of a nice creamy thing. So you don't want both lemon juice and milk in your tea. All right. So just pour the vinegar into the cup with the eggshell. And then use the dropper to squirt some vinegar into the egg white. Just a couple of drops. Yeah, do a good squirt.
Oh, let's put the eggshell on that one.
Just take this bottle and just pour it in. That's why I give you a good amount in the cup. So this is the one that has the vinegar in it. So I'm gonna change a little bit. Not as quickly as I thought it would. So this one has vinegar in it. This one put. And see if we can get one of the. I can't. It's probably the same amount acidic. That one would have both malic acid and acetic acid, but the concentration is probably pretty similar. Oh, so I'm gonna borrow yours. Okay, so for those of you at home, this is a little bit hard to see, but we can see a little bit of a difference on this. Let's see, I have darker background. Okay. Okay, so the cup on your left has some acetic acid in it, and you can see it's starting to turn the proteins white, and the cup on the right does not. And so that is the clear albumin. So that means that the vinegar is starting to denature our egg whites there. All right, thank you for letting me know. With the eggshell, it might be really hard to see, but there are tiny bubbles at the bottom of this. And I'm not sure how well those are showing up, but you can see tiny bubbles on top of the eggshell if you're in person. All right, so obviously it's not going to dissolve the eggshell instantly. It's going to do it a little bit at a time. Acids in our foods do the same thing to our teeth. So our teeth, the enamel has a lot of calcium in it, similar compound to what's in the eggshells, which is why it's important to brush your teeth to wash away some of those acids. Also, little bits of food feed germs that sit in like the nooks and crannies in your gums and in between your teeth, and they produce chemicals that also break down your teeth. So that lots of combinations. But sometimes dentists will worry if you are somebody who drinks a lot of soda, and they may suggest, instead of drinking it from a cup, drink it with a straw. And that way you're bypassing your teeth and going straight down your throat. I tend to be one of those people that I like my drink to sit in my mouth, and I enjoy the sensation of the warm coffee in my mouth or something. That's probably really terrible. Okay. So another way that we use acids in cooking is ceviche cooking. I've never had this. If you think of sushi, we think of that as being like an Asian dish, usually Japanese, where it's raw fish. So ceviche would be like we're starting with raw fish and we're going to cook it, or some people, instead of saying cooking it, they say they're curing it by soaking it in lime juice or lemon juice. So lime juice and lemon juice, remember, are among the strongest acids that we would ever consume. So they take the raw fish, submerge it in that juice, and that denatures the proteins in the meat. And theoretically, that would also denature the proteins in any germs that might be there. But just like with sushi, you want to be really careful that you have good fresh fish, because if it's fish that has been sitting around for a long time, the acid's not going to be enough to destroy all of that. So if you ever want to try ceviche, just make sure you're doing it at a place where you trust that they're using the good fish. Let me put this back up here. There we go. Okay. And like I said, I've never had this, so I don't know a lot about it, but the proteins get denatured. It's not just lemon juice. There's going to be other spices in there. There's a Mexican dish that's similar. I just heard about this, so I don't really know a lot about it, called aguachile. And that also is soaked in an acid. And I think that roughly translates to like spiced water, spicy water, something like that.
That makes sense.
All right. So we can use acids to cook our foods. All right, so what do you need to know? If we have a quiz next week that covers this, well, we will have a quiz next week that covers this. If I give you a pH, tell me, is it an acid, base, or neutral? So remember, below 7 is an acid, above 7 is a base, 7 exactly is neutral. That list, that chart that we did on the very first thing on the back of your first page in your guided notes that separates them by what is the taste or what does it neutralize, those kinds of things. If I tell you which tastes sour, an acid, a base, or something neutral, you're going to tell me the sour things are acid. Okay. And then I might say what kind of food might have acetic acid in it. So I probably, well, I mean, it's in your nose, so I guess since it's in your nose, it's fair game to ask the malic or the tartar, but I am more likely to ask the ones that were both, the citric, the acetic, because that's vinegar, lactic, because that's so similar to lactose. Those are things that you should be definitely, but I may ask about the others. And then I might give you some chemical formulas and say, which of these is an acid? And so you're looking for two things. Is there a hydrogen out front? If it is, that's the acid. If none of them have a hydrogen out front, you're looking for that COOH at the end. Okay, so the organic acid has the COOH. And then the other thing I might do is I might show you a picture of a chemical. So Dr. Hughes left this lovely picture here. Let's take a look at this. All right. So if I said on a quiz, circle the carboxylic acid on this, what are you going to do? And let me make this so you guys can see this. So there are carboxylic acids on 2 of these molecules. One of them does not have a carboxylic acid. So first of all, if we number them 1, 2, 3 from the top, which one does not have a carboxylic acid? Number 3 does not have the carboxylic acid. Very good. Okay, so where are the carboxylic acids on the other 2? Remember that where I don't have letters, these corners here are carbons, right? So there's a carbon, there's a carbon, there's a carbon, there's a carbon. And that carbon needs to be attached to how many oxygens? 2. Okay, and then one of those oxygens is going to have a hydrogen. All right, so this right here is a carboxylic acid. This is carboxylic. All right, now these others have functional groups we've talked about before. So to review, what is this one down here that has the N in it? Nitrogen is part of that's an amine, so that's a good one to know. All right, and then this guy hanging out over here, the OH, what's that called? That's the one we probably talked about the most. That one is going to be an alcohol. All right. I don't usually show them this way. This here is also a carboxylic acid because it has the 2 oxygens. They've just put the 2 together. So it's a CO2. And then this is an amine. So if it has both an amine and a carboxylic acid, we call this an amino acid. That's a particular kind of amino acid. Okay, so So for Thursday, what I would like you to do is take a look at interchapter 4. That is on the organic functional group. So we've talked about a few of them just now, the carboxylic acids, the alcohols, the amines. We're going to look at esters. So esters also appear in a lot of foods. They affect the way we perceive flavor because they have a scent associated with them. And so we're going to smell some different not carboxylic acid, some different esters on Thursday and see if we can identify which of those carboxylic acid, which of those esters are associated with which things. A lot of times they're going to be floral things or fruity things. There are a couple of them that are just super identifiable. So that's one of the things that we will do on Thursday. All right. Any questions? All right. Those of you that showed up online, thank you very much. I appreciate that. And hopefully I will see you all on Thursday.